the basics of this course. Now, we have started with this drives and load. What was the need for control, and then we moved to the basic model of the plant, where we discussed that if we have a input and the plant will respond to that input in a particular format. So in the task of the control engineer will be to have a output y bar which will be equal to the reference, or our target will be to achieve y bar t near equal to RT even when a disturbance dt signal is present. So therefore, the controller that we are going to design in this course, or we will try to learn about how to design this controller in this course. So the objective of the controller will be to generate this signal u bar t. Okay, so in this process we have also learned the problems related to the objectives related to the controller design, and then we moved to the structure where we discussed what will be a open loop control. That is, the controller the control effort u will be generated based on some predefined function for which the y will follow the reference signal r. And from that we have discussed this, that if we know the model of the disturbance, so we will have a better design for the controller structure, which will be taking in it will take the reference signal and the disturbance signal into the design criteria of that controller, so that it will design u based on the r and d signal. And finally we came to the structure of a feedback control, where, so in these two cases I have already discussed that this is just the summary of the previous class. That in the first case we have discussed that the d, that is the disturbance signal, it may come from as we have discussed, I don't know whether you remember or not, as it may come from the source or the sink. Do you remember this? The disturbance may come from the source or the sink, the equivalence of this source and sink and drive and load for practical cases we have also discussed in the last class. So as we have discussed, the disturbance signal is not always, or most of the times, the disturbance signal is not known. That is the disturbance signal cannot be modeled as a whole. So some part of, if we know some part of the disturbance signal, we can take into account for this second case. That is, somewhat it will be better than the first case, but we will never be able to model all the disturbance that are present in the system. Therefore, we have taken the example of the room heating problem, where there were two types of disturbance. So we will I guess you remember. So finally we came to this structure of the controller, where the controller will take its measure. That is, it will generate the signal u based on the reference signal as well as the measurement of the output which we are trying to control. That means it will use a sensor in the feedback loop. That is, in this loop it will use a sensor, and using the output of the sensor along with the reference signal, it will generate the control input U. So in the discussion of this controller design, there is the idea of what will be the basic idea for controller design in this course. So everywhere we have used this block plant. So that means we are interested in controlling this block, that is the plant. We have taken that plant could be a process, chemical process or industrial process. It could be a mechanical system, it could be a thermal system, or it could be some data driven system. Okay, so whatever the plant is, we are here to have an output which is our desired output from that plant by giving it some kind of input. So that part is a next step for our, so a basic idea is to design a controller, but for moving forward we have to first understand what is this block, what is this plant. So for that we need a description of that plant, which we are trying to control here. That means some kind of output response we are trying to get from that plant. So therefore input to output relation of that plant should be described somehow. So this process of describing the behavior of the plant in terms of the input and output of the plant, it will be called the modeling. So in this class we will try to understand what is modeling and what are the techniques for modeling of a system. So basically there are largely we can classify the modeling of a plant in three categories, that is behavioral model, statistical model and mathematical model. What is behavioral model? When behavioral model will give the input to output behavioral relationships. Means say if we are talking about a system where so can you tell me uh, if you are talking about first, have you seen any structural models of any plant? So there are students from different departments, na? Mechanical and civil students are there. So what in case of a say you are modeling a power plant, so what kind of model you show? Yes. So if so you have this pictorial description of a power plant, you try to represent this is the power plant. Say if somebody says uh, for this water cooling plant I need a model of that water cooling plant, what kind of model you will propose? How will you describe that model? Yes. Hmm. Yes. So that is a structural model you will represent. That is where the parts and the machines and turbine those are placed and how they will be arranged. That is a either it will be a 2D model or 3D model, or it will be a pictorial description. So that is also called model. So that is a structural description. that is for that will come under the first category, that is the behavioral model. So either by words or pictures or 2D or 3D diagrams or 3D models, you will describe the structural system or its behavioral property. Okay, so that comes under the first category. Second category is where there are for a system or for a plant, if there are uncertainties involved, so then the input and output signals will not be deterministic, they will be probabilistic signals. So the model itself should be described in terms of statistical measures, like its average values or means or deviations and forward the related orders according to the need of the system or complexity of the system. So that kind of modeling will come under statistical modeling. Now the third category is mathematical modeling of a system. That means we will try to describe the input to output relation of the plant in terms of some mathematical equations. Okay, and from where do we find these mathematical equations? We will have them from the physical properties or physical laws involved in the system. Okay, so first thing is, for the mathematical model, the first assumption that we are taking, what is the difference between this statistical model and mathematical model? For the mathematical model, the first assumption we are taking is the input, the signals involved in the system, the signals involved are deterministic in nature. Okay, and the rest of the discussion in this class we will be doing on this mathematical model of a system.
Ma'am, can you explain what do you mean by signals are deterministic?
Signals are deterministic when at any point of time you have the complete description about the value of the signal. See here, if we signal means that is a physical quantity represented in a say see I guess you have understanding of signal. Say if I describe a signal y, it will be, it will have a independent variable, it will be a function of an independent variable. It could be time, it could be space, it could be a function of both space and time. Okay, so the value of this y for a particular value of this independent variable will be fixed. Is it clear?
Yes, ma'am.
Okay, so we will this will be our assumption for the rest of the course. So we'll deal with only deterministic signals. This, so say the plant actually, so first let us take, say inside the plant we have only this kind of, only a resistor, sorry, okay, Excuse me, my pen is not working properly. Okay, let me. Okay, so this is a series combination of two resistors, R1 or R2 say. Okay, and the plant we are talking about is actually taking the input Vi. Okay, so then now the plant, that box of that plant is not a black box to us. So let us assume that inside the plant there are two resistors connected in series. So the input to the plant, so input to the plant is the Vi, that is input voltage Vi, and the output signal we are taking the V out, that is the voltage drop across the resistance R1 as the output. Okay, so what will be the relation between Vi and Vo?
VA equal to VI into R1 by R1 plus R2.
R1 plus R2. So if we change Vi abruptly, say if I provide a say from I provide this is the signal Vi with time, and I provide a 1 volt input first, and then suddenly I change it to 5 volt. Okay, so what will happen to V out? The particular time at t0, I change this input from 1 volt to 5 volt. So how V0 V out will change? Will it change abruptly at time t0, or will it take some time to move to some value? It is, there will be a change in the value of V out. Do you agree? So
Yes, ma'am.
your answer was V out is equal to R1 by R1, sorry, R1 plus R2 V1. Say this constant, this R1, if I fix R1 and R2, this will be a constant. Is it okay?
Ma'am, I guess for resistors the
Hmm?
change will be abrupt, but in case of capacitor or inductor, the change should is
Yes,
actually
yes, that is what we are trying to come to. So in case of resistors, this will be, the change will be abrupt, you're saying. Okay, so this kind of system we will call it a static system. Why static? Because if there is a change in the input, instantaneously there will be that change will be reflected in the output. Okay, so this kind of system will be called as static system. So there is no dynamics involved. No dynamics involved. So what do you mean by dynamics? So another example could be of this static system. Another example could be damper. Say if we connect two dampers B1 and B2 in parallel, what will be the equivalent damping in these 2 points? What will be the equivalent damping for this? So we have assumed there are two dampers B1 and B2 connected in parallel. This point has a displacement x. The first point, this point has a displacement x, and this point has a displacement y. So what will be the force to velocity relationship?
If equal to C into V
V
dot right?
into H dot minus Y
C
dot.
into V.
Yes.
Ma'am, if equal to a constant into ma'am x dot.
H dot minus Y dot.
Yes. So it will be B1 y dot minus x dot. That is the resultant, plus for the first case, for case, which
B2
case?
into Y dot minus X dot.
Yes. And B2 into y dot minus x dot. So it will be B1 plus B2. So the equivalent damping factor will be B1 plus B2. Do you agree? So this
Yes,
is
ma'am.
also, so this is also, if we change the input, the output will, if there is a abrupt change in input, the change will be abrupt in the output as well. Okay. Why this is happening? This will be the same for any if you take any combination of this is a series combination. This is a parallel combination of the damper. What will be the equivalent resistance in this case? What will be the equivalent resistance from this point to this? I took this example. I thought there are mechanical students, so it will be
Ma'am, actually the
resistors. If I show, that will be a problem, I thought. But
yeah, ma'am. Actually, in series case, ma'am, the two displacements will be correlated to each other, ma'am. There is no
yeah,
independence, ma'am.
but I am asking for the equivalent damping ratio. What will be the equivalent damping ratio from x to y? In this case, we can say the B equivalent is this, na? B1 plus B2. What will
Then,
be the,
I guess 1 by B1 plus 1 by B2 equal to 1 by B2.
now that B equivalent will be,
B1 into B2 by B1 plus
yes,
B2.
yes, B1 B2 by B1 plus B2.
Series parallel case is just interchanging in.
Yes. So this is there for resistance also. If we take resistance in series, this will be similar to the resistance in parallel, and this will be similar to the resistance in series. Yes. So whatever may be the connection between, say, the point here is, if we take a element which is static in nature, so if we take multiple of that element and we combine that in any combination or any structural this interconnection between this element, we will get some equivalent value. But the point is, the input to output relation will always be static. If we change the input abruptly, there will be a change in the output that is also abrupt. Okay, so the point here is, if we have, say, in the next circuit, if we have R and C, what will be the effect? What will be the effect? Can you tell me?
And this is not a
This will be not be a static
yeah,
output.
ma'am.
Output is a
Yes,
transient case.
Yes.
there
If
should be a
we change,
transition state, ma'am.
yes, if we change the V in like this, say, if I change V in like this is my V in. The output will be changing like this.
Yeah, ma'am. Exponential function will be
So
there.
why this happens? Can you tell me why? What is the reason behind this?
Uh, because, ma'am, to charge the capacitor, it will take some time, ma'am. So
Time.
that is
Yeah.
right.
The charging is exponential curve, I think, for the
Yeah,
That
capacity.
ma'am.
is
So
true.
the
That is
V0
true.
equal to Vi into e to the power minus RC by RT by RC, I guess the equation was.
So charging means it will depend on something. Why you are calling it charging?
Because, ma'am, it is storing some energy.
So the key point is here in this plant there is a energy storing element. Energy
Yes, ma'am.
storing element means it has something to tell. It has some information. If you don't know, somebody said it will charge. It will charge. So will it charge for it will charge for infinite
It will
time?
charge for a certain time.
But why?
No, ma'am.
Why it will charge for a certain time?
Because ma'am, it has a certain capacity. After that, it will start discharging.
So that means it will start from somewhere and it will end somewhere. So it has some capacity. And
Yes,
if you don't know what is the state it is right now, how much energy is stored in the element right now, you cannot predict how it will react with the input. So here comes the twist that this type of circuit where there is a energy storing element involved, the output is not only dependent on the input, it also depends on the
elements.
present condition of the energy storing element. In the previous case, you were not bothered about what was there with the damper or what was there with the resistance, what was the condition of the resistance, no. But
Yes, ma'am.
in this case মাউসটা মাঝে কাজ করছে না আচ্ছা তো in this case what will why in this case what will happen, say if the capacitor, say I have given a 5 volt input, the capacitor initially was at 3 volt. So how the response of V0 will be? So V0 will be moving from 3 volt to its final stage.
Yes, ma'am.
It will not start from 0 volt. So that means the output V naught does not only depend on the input, it also depends on the current state of the energy storing element. And this we can see in any, so we will have a similar to the resistance damper equivalence, we will have a similar element in the mechanical system. We will have a similar element in the temperature control system. We will have some equivalent in the say flow of a say tank and this pneumatic flow system. We will have some equivalence of this element, but the basic element is a energy storing element, and the nature of the thing is the voltage here V naught will be actually 1 by C into the charge stored in the system. So what is the charge stored? That will be the current in the circuit times dt.
Into it.
This is the relationship. Okay, so we can write the relationship between Vi and Vo now in this format. Say this equivalent, this can be rewritten as C dV0 dt is equal to I. And what is I from this?
VI equal to VI by
Vi minus V naught by capital R.
capital R.
Do you agree? So now we can write, finally we can write the whole system using I have a problem with this pen. Huh? Please bear with me. Okay, so finally we will have, if we combine these two equations, what we will have, we will get Vi will be equal to R into C huge problem. Okay.
Yes, ma'am.
What kind of equation this is? This is a mathematical description of this plant. So what kind of equation this is?
First order differential equation.
Differential equation. So in the previous case, it was a algebraic equation. This V out and Vi relationship was a algebraic equation.
Yes, ma'am.
Okay. So so this type of system we will call it, where we can relate the input and output of the system using differential equations. By differential equation I mean integral differential equations. If there are integral, this was actually the relationship between I and V not was actually a integral type of relationship. So integral type of relationship can be easily converted into a differential relationship. So therefore the integral differential kind of equations, we will call it in general a differential equation. Okay, so the systems which are dynamic, that means the systems which are having energy storing elements within them, those will be called as dynamic systems. They will have, how do you understand that, how do you get that that this system is a dynamic system? How do you experimentally get it? If you provide a abrupt change in the input, you will see there is a transient response present in the
In the out.
so therefore we will call that system a dynamic system. And the property of the system is actually, so by the seeing that output, you will understand that there are energy storing elements involved in the system. And the order of this differential equation actually give us the number of independent energy storing elements present in the system. Okay, in this case, for this RC circuit, there was only one energy storing element present. So therefore the order of the differential equation actually represents, that is the order of the differential equation here is 1. So it represents that there is one energy storing element. Another thing, you see, if you see the coefficients of the differential equation, you will find, so what are the, do you understand what is coefficient of the differential equation? What are the
Yes, ma'am. I'd say
coefficients? RC, and this
it's
we
one.
we not also, yes, there is only constant. So if there are only constant coefficients involved in the differential equation, the differential equation actually with constant coefficients here in this case, so therefore we can say that the system will be linear and time invariant. Okay. Next, we will move to a, say, water level control system. So control part will come later. First, let us model this water level, tank water level control problem. That is, the input to the plant is this inflow. So the inflow here. So forget. So first let us. Okay, I'll discuss it. Okay. So say there is an inflow. It is shown. Is it visible or?
Yes, ma'am. Yes, ma'am. It is
So
visible.
inflow here the inflow, I have taken this from the book of Ogata. So they have given this okay notion. I'll explain the notion. After that we will come to our discussion. So first, the input flow to this tank is denoted by Q bar plus Qi. Okay, so what they mean by this Q bar is, say, a particular steady state value of this flow. Q bar flow is coming to the tank and Q bar flow is going out of the tank. So that flow is there, that particular flow is there. By controlling this valve, what we are doing, we are changing this Qi. Okay. So this Qi is the input to the tank, Qi plus Q bar. And for that, the present height of the water level is H bar plus small h. This capacitance of the tanks, the capacitance, you can call it, if it the cross sectional area is this is a uniform this tank is with uniform cross sectional area, so we can call it the cross sectional area. So, and then the water goes out through this valve, load valve, and resistance of the load valve is denoted with the value capital R. And this is our output flow, which is Q bar plus QO. Okay. So how will I write the mathematical description for this plant?
Q in minus Q out equals to
Huh.
DHDT.
Only DHDT? Volume,
Area
no?
into DHDT. Area into
Yeah,
DHDT.
area into DHDT. True. Good. So we will write it like, so Q bar and Q bar, say this is complications from the book. Okay, so the in flow we can write Q bar plus small Qi. Then Q bar will cancel. Uh, of Okay, so let me write. This is Qi minus Q bar minus it will be equal to C Do you agree? So therefore, we can
Ma'am,
come to this model that
see the cross sectional area, ma'am.
C. Yes, yes.
Cro-
Say, actually, why they have written C? Say if this is not uniform. So, if we go for if we go for a tank which is not having a uniform cross sectional area, so what we will do? We will define C as the capacity of the tank, where it is the value that is for change, the volume of the volume of the water uh, by unit change in height. Okay, volume of the water flow for which there will be unit change in height of the tank, that will be defined as the capacitance. So if it is a
Okay.
uniform cross sectional area, then you can directly call it the cross sectional area.
Okay.
Otherwise you have to go for this generic term. So we can now write Qy minus Q naught is equal to, sorry, Qy minus Q naught equal to C. This H bar is the steady state height. So I'll that is a constant value. So we are only bothered about the change in the small h. Okay. So this we can write as the volumetric flow, the equation related to the volumetric flow. Now, can you tell me what will be the relationship of Q naught? What will be the value of Q naught? Is there any
Root
relation?
over
Yeah,
eh, root over 2g h bar plus h into
yes,
the area of the pipe, I think.
yeah. So there will be a constant related to this resistance and the capacitance of this tank, and we can write in a simplistic fashion. A Q naught will be equal to some constant sigma of sigma, একদম লেখা খুব ওকে। এটা আমার অবস্থা হয়েছে না একদম সেই প্রাইমারির হাতের লেখা প্র্যাকটিস করার মতো। না এটার বোর্ড কাজ করছে। Okay, so it will be equal to root 2g h plus small baba h plus small h, মনে হচ্ছে একটা ব্ল্যাকবোর্ড ফেলে আচ্ছা এটা হচ্ছে h bar plus small h, ঠিক আছে। Okay, so this output flow will actually depend on the height of the water level in the tank. Do you agree? So therefore the input to output relation what is the output of in here? What is the output here in this system? If we see it as a plant, what will be the input and output of the plant? What is the physical variable that we are trying to control here?
Flow rate.
No, flow rate we are not trying to control. Flow rate, we are trying to control the water level.
Okay.
Because okay, so our input here is to change the inflow rate in the tank, that is Qi. This value of the water level and the outflow rate, they are not independent. Only one of them you can control. Do you agree?
Yes, ma'am.
Qi is our input and say H is our output. One second. H is the output. So therefore, what will be the input-output relationship here? We can write C dH dt plus, so if we can take root over 2g as constant as well. So some constant which is actually dependent on C, capital R, all these values of the system, that there is the system parameters, and ultimately depends on root over of H. Do you agree?
Yes.
So now, is it a differential equation? The mathematical description of this plant, is it a differential equation?
Yes, ma'am.
So that means if it is a differential equation, that means the system is a dynamic system.
Yes.
What is the nature of the coefficients of the differential equation?
Constants.
Constants. Is it?
Yes.
How do we represent a differential
No,
equation?
C is not, I think, constant. The area
No,
may
C is
change.
constant. C is constant. You are right that C and K are constant. No problem. But look at this term. Look at this term with K. There is a root H.
Yeah.
So how do you define a differential equation? In case of a differential equation, this Qi should have been a function of H dH dt, d2 dH2, all these things.
It's a first order differential equation.
First order differential equation. That means there is one energy storing element in this system.
Yes.
What is the energy storing element here?
The tank itself is
Tank
the
itself.
energy.
So tank is storing actually uh,
The water.
water, and then energy stored. Somehow in the
Yes.
tank there is energy stored. So there is only one energy storing element here. So that's why the order of the differential equation is 1. That is okay. The order of the differential equation is 1. But whether this differential equation is linear in nature,
No, man.
it is not linear in nature because of the term root H.
Yes, ma'am.
Okay, so what are the things then we have to see in a mathematical model? First, we see whether the equation representing it is a algebraic equation or a differential equation. Okay, so if it is a algebraic equation, that is a static system. If it is a differential equation, that means it's a dynamic system. Then we see what is the order of the differential equation. Whatever, if n is the order of the differential equation, that means there are n energy storing elements present in the system. Therefore, the order of the system is n. That is, the system is nth order. Now, then we have to check for linearity and time invariance. So how do you check? If the differential equation is linear in nature, that is,
Non-linear.
this one is nonlinear, therefore the system is nonlinear. If we want to check for the time invariance property, how do we check? We will see the coefficients of the terms, whether they are function of the independent variable or not. So first let me add one page. So first, what are the things we will check? We will first check whether the system is static or dynamic. How do you check?
Whether
How do you check?
the
Whether the
equation is
equation
algebraic equation.
if it is algebraic, then we say it is static. That means if there is a change in input, instantaneous change in input, there will be instantaneous change in the output, and it implicates that there is no energy storing element. Oh, no energy storing element. Okay, if the system description, mathematical description is with differential equation, we call it dynamic, and it implies that there are energy storing element present in the system. আচ্ছা, second হচ্ছে how many independent energy storing elements will be there?
The order of the differential equation.
Order of the differential equation, and that will be order of the differential equation will give me the order of the system. So in general, how we can write a differential equation? In general, how do we write a differential equation? We can write, say, the input of the plant is Vi and the output of the plant is Vo. So therefore, we can have or if I write it in terms of X and Y, say if I have a plant, the input to the plant is X and output of the plant is Y. So the what will be the generic representation? Generic differential equation representation? Oh. and the coefficient could be, so the first coefficient that corresponds to the nth differential term could be a function of y could be a function of y, x, and t. Do you agree?
Yes, ma'am.
So therefore, this is the generic representation. Say I can write it from এটা একটা কম এটা এই ফর্মে লিখে দিই কারণ আমার পেনের খুব প্রবলেম হচ্ছে, এত বেশি আর টার্ম লিখতে পারছি না। 1 to n we can write it. So we will I'll have it ci. তিনটে বই রেফার করা আছে, তুমি যে কোনো বই ফলো করতে পারো, সেম মেটেরিয়াল পাবে। আর এই যে পিপিটিটা আমি পড়াচ্ছি আমি ওটা শেয়ার করে দেবো, অসুবিধা নেই। আচ্ছা, আগে এটা একটু শুনে নাও মন দিয়ে, হ্যাঁ? তারপর খুব এটাতে অসুবিধা, যাই হোক এটা একটা ব্যবস্থা করতে হবে। হ্যাঁ, তো যেটা বলছি এটা প্লিজ I দিয়ে লিখলাম এটা, বিকজ I could be 1 to হ্যাঁ আচ্ছা, so now try to understand this. এটা কি I দিয়ে বলছি কোনো প্রবলেম হচ্ছে বুঝতে? There is a ith derivative of y. হ্যাঁ, ith derivative of y is a function of t. Okay, so ith time derivative of y and the coefficient corresponding to that could be a function of generic y, x or t. হ্যাঁ, এটা এখান থেকে কিচ্ছু লেখা বোঝা যাচ্ছে না, আমি আরবার লিখছি। It is a function of, in general it could be a function of x, y or t. হ্যাঁ, তাহলে এবার, and this varies from 1 to n, we are saying. That means c1 dy dt, then this could vary from 0, I think. Yes, obviously, because constant term also could be there is only a function of c, y and t, and then after that it is varying with this. So that means there is a constant term. Constant means there is a function of x, y and t, and after that the first derivative of y. Second term consists of the first derivative of y, then second derivative, then up to nth derivative of y, and this is equal to xt. If this is the differential equation representation of the plant, so from here what are the observations we can make? So if the equation, if n is greater than 1, greater than or equal to 1, that means it is a dynamic function. If only I equal to 0 present, that means it is a static or algebraic, this is a algebraic representation, so therefore it will be a static system. Now the value of n represents the order of the system, and whether this function, if all the CIs are only function of uh, only function of t, therefore we can call it only function of t, then that means constant or function of t, therefore we will call it a linear system, because it is the coefficients are not dependent on the input or output function. Therefore if we provide a input x1 and we get output y1, then again I provide a input x2 and I get a output y2, then the superposition of these two inputs will result in a superposition of the outputs y1 and y2. Therefore, by seeing the differential equation, if all the CIs described here are only function of t, or they are constant, then we can call it a linear system. Okay, if the CIs are function of only the CIs are constant, they are not function of time, then we will call them time invariant. And if there is time involved, then they are time varying system. Okay, so say if we extend the problem now to a coupled tank, that means there are two tanks involved. First the input is q bar plus small q, and then the height of this first tank is h1 bar plus small h1. Then water flows from the first tank to the second one through this valve, and the resistance of which is R1. And then from the second tank itself, the outflow is q bar plus q2. And we are trying to control the height of this second tank, say for instance. So can you tell me how many energy storing elements are there in this system?
Two energy storing device.
Two energy storing elements. And what are the variables that will indicate the status of the energy storing elements?
C1 and C2.
No. C1 and C2 are the cross-sectional area of the tanks. I am talking about the status of the system, and uh, how much
H1 and
energy is
H2.
already stored in that energy storing element.
H1 and H2.
H1 and H2. So H1 will denote that how much energy is already stored in the tank 1, and H2 will denote how much energy is stored in tank H2. Do you know the significance of this problem? Couple tank system. Have you seen this system before?
I think to maintain the constant water level at tank to always.
Have you seen this structure? I mean, where it is
Yes,
used?
in the hydraulic system we have seen that when
In hydraulic system, you have seen. Okay.
when we need constant flow rate
Hmm.
or the constant velocity, then
Huh.
when the flow is uh, when the input flow is more, then there is I think a drainage system through
Huh.
which the extra water is flown out.
Yes. So your objective is to have a constant Q2.
Yes, ma'am. The
And
constant
in
flow.
that system, what is this tank 1?
I don't remember this time.
That is a storage tank.
Okay.
Huh?
And yes, ma'am. Yeah, this is the storage tank.
Okay,
And
so we have this couple tank has a practical implementation in the distribution, this water distribution in the in the cities also. So this is the tank one is the storage tank, that is supply, where the supplier actually stores the water, and then this H2 is the uh, is the local tanks from where we get our water flow. Okay, so the objective is the calculation that everybody should get a constant water flow in their house. They should have some they have subscribed to that water supply system. That means they should have some uh, there is a particular value for this Q2 that to be supplied to the household users. And
yes,
for that the calculation has been made that what should be the water level height for the local tanks H2. Okay, that calculation has been done. So now what is the problem here? Why we are discussing this problem? Because control of this couple tank system has its significance, and it is very very important problem. Just now you told me that it is used for the where you have told that pneumatic system, sorry, hydraulic system.
yeah. I think we were performing the Reynolds experiment
Reynolds
apparatus.
system.
There
Yes,
was
so
a
actually, in our hydrogen laboratory, there was an apparatus called, as you mentioned, Reynolds testing apparatus.
There
So
you
in
have
that
used.
apparatus, yeah, ma'am.
Okay. Okay. So there also you need a particular Q2.
Yes, ma'am. Yes, ma'am.
yes.
To maintain the flow, ma'am. Actually, there was a K104 line.
Hmm.
To just visualize that line, we need to maintain a constant flow rate.
Okay.
Constant flow rate. Yeah.
Ah. Then why the two tanks are involved in that case?
Ma'am, because the first tank is not sufficient enough to maintain the flow, so the storage tank basically comes into picture to, make that flow sufficient enough to just
Actually, ma'am, the fast tank was involved because when we were like we were not using the apparatus
Huh?
when the apparatus was idle, but the here you can see that the Q dot plus Q, that is the entry flow rate, was
Yes. Yes.
continuous, and
Yes.
in that case that H1 plus there was a drainage pipe, I think, through
Very
which
good.
the
Very good. So that is the significance, because why we need this two couple tank system, because the disturbance in the input and the
yeah
disturbance in the output are
output.
not modeled. This kind
Yes,
of
ma'am.
system is only used for systems where the input flow is not in our control, or not cannot be properly modeled.
Model, yeah.
And second thing is that output flow Q2, that need for this one, say this R2, this valve R2 represented by this resistance of in this valve, this will change time to time, because some of the users will be using the flow, that is a time varying function.
Yes,
Sometimes
ma'am.
four houses will be taking the output water, sometimes it will be two, sometimes it will be 10. So that flow also is not cannot be modeled,
Yes, ma'am.
cannot be taken as
But
a
we have to
constant.
maintain
So
the
there
H2S
have, in that situation also, we have to maintain the height of this tank H2.
second type constant.
Yes, at some value. So that is why this is significant, this problem. Now if we try to write the differential equations involved to describe this system, what we will see, say for the first tank we will write that small q minus q1. So for the first tank, let me write, so q minus q1 will be the change in the uh, first tank. What is that? C1
Into DH1, right?
dH1. Do you understand why I am skipping this q, capital Q bar and capital H1 bar?
Yes,
Obviously,
ma'am.
because ma'am, capital Q bar will be cancelled out, and H1 bar is basically a constant. So it will
Constant.
be,
Therefore,
Derivative
the
of constant is 0.
okay, very good, very good. Okay, so therefore, this will be the equation, volumetric flow equation for the first tank, and then for this, and what will be the Q1? Can you tell me what will be Q1?
Q1 will be K into root. I think Q1 equals to root over 2G into H1 bar plus H1.
Yes, yes. So Q1 is actually dependent on, or it will be proportional to
Root
root
H.
over
Root H1.
H1 minus H2.
H2. Yeah,
Okay. So this flow is dependent on the difference between these two heights. Okay. So therefore we can replace Q1 using the constant like Q1 is equal to K1 root over H1 minus H2. Sorry, this is, there will be little bit correction. This should be root over some constant K1, because this will depend on the pressure difference. You should this will be K1 root over H1 minus and what will be the equation for the tank 2?
Q1 minus
Q2 minus Q1
Q.
will be C2 dH2 dt. And H2, sorry, this Q2 outflow rate will be dependent on only the height of the second tank.
ম্যাম
Second
এই
tank.
ইকুয়েশনটা না ঠিক লাগছে না ম্যাম, মানে ওই Q1 প্রপোর্শনাল টু দিয়ে যে ইকুয়েশনটা লিখেছেন, আই ডোন্ট থিংক দ্যাট ইকুয়েশন ইজ কারেক্ট ম্যাম।
হ্যাঁ, এটাকে তুমি ডাইরেক্ট এই রুট ওভার 2gh ইউ ক্যান রাইট ইট অ্যাজ এ ফাংশন অফ h1 মাইনাস h2 না, সেটা প্রপোজ করছো তো?
ইয়েস ম্যাম, দ্য রিজন হচ্ছে আপনি যদি ওখানটা বার্নৌলি ইকুয়েশন যদি ইউজ করেন তাহলে
একদমই তুমি ওখানে রুট ওভার h1 তুমি যদি ওটা ডাইরেক্ট ইউজ করে দাও, তাহলে h1 মাইনাস h2 লিখতে পারো, তাহলে তোমাকে আর মাঝে এই হাইট ডিফারেন্স নিয়ে ভাবতে হবে না, ওটা তুমি লিখতে পারো। তাহলে কনস্ট্যান্টটা তুমি টেক কেয়ার করে নেবে দুটোর জন্যই, মানে দিস কনস্ট্যান্ট উইল ডিপেন্ড অন C1 এন্ড C2
ইয়েস
both.
ম্যাম।
ওকে, তাহলে ওটা তোমরা অ্যাকচুয়ালি এখানে না আরেকটা কমপ্লিকেশন থেকে গেলে, এটাকে এত ইজিলি লিখবো না। দিস H1 বার আর H2 বার এখানে থাকবে ভেতরে, ঠিক আছে? তাহলে
হ্যাঁ
আমি
ম্যাম,
এটাকে
ওটাই বলছিলাম।
ইয়েস ম্যাম, মানে অ্যাকচুয়ালি আমাদের এটা লেখা উচিত ছিল বার্নৌলি ইকুয়েশনটা ওখানটা পুট করে ওই দুটো পয়েন্টের মধ্যে পুট করে তারপর লিখলে।
এক্স্যাক্টলি যদি আমরা এক্স্যাক্ট মডেল করতে চাই, তাহলে আমাদেরকে লিখতে হবে, সেটা আমরা করব। অ্যাকচুয়ালি এটা জাস্ট, আচ্ছা তুমি তাহলে আমি একটা কাজ করছি, এটাকে
বার্নৌলি দিয়ে করি।
বার্নৌলি দিয়ে করবে, তাহলে তো কনস্ট্যান্ট গুলোও পেয়ে যাবে R1 R2 দিয়ে যদি লেখো। হ্যাঁ, R1 R2 দিয়ে ডাইরেক্ট পেয়ে যাবে। আমরা R1 R2 এর কমপ্লিকেশনে যেতে চাইছি না, R1 এখানে কনস্ট্যান্ট, R1 R2 কনস্ট্যান্ট ধরছি, ক্যাপাসিটি, তাহলে জাস্ট এটাকে আমি এইভাবে লিখে রাখছি, একটা কনস্ট্যান্ট নিলাম যে কনস্ট্যান্টটা ডিপেন্ডস অন C1 R1 C2। হ্যাঁ, দিস কনস্ট্যান্ট ডিপেন্ডস অন দিস। আমি শুধু এই রুটের ভেতরে, হ্যাঁ রুট ওভারের ভেতরে এই ক্যাপিটাল, ওফ বাবা এক মিনিট, এই এখানে আমি ক্যাপিটাল H1 বার রাখলাম প্লাস স্মল h1 মাইনাস capital H2 bar তাহলে আমি এরকম রাখলাম this function, this k will be a function of c1 c2 and r1 ওটা derive করে নেবে ঠিক আছে আচ্ছা and this q2 will be a function of
ম্যাডাম ওটা q1 মাইনাস q2 হবে, q1 তো ইন হচ্ছে আর q2 আউট হচ্ছে, তো ইন ইকুয়াল টু আউট প্লাস টোর,
হ্যাঁ q
q1 তো ইন হচ্ছে।
thank you q2 will only depend on, তাহলে আরেকটা কনস্ট্যান্ট নিয়ে নিলাম k2 and এটাকে শুধু লিখলাম root over, it will only depend on the height of the rank 2 তাহলে h2 bar h2 bar or h2. Okay, so now if I try to write the whole thing, what will be the relationship between the input q and the height h2? What will be the relationship?
ফার্স্ট দুটোকে অ্যাড করে দিলে আই থিংক q1 কেটে যাবে।
Yes. So then we need to write q1 and q2 we will get in terms of, we will put q1 and q2 here, and from there we will try to replace q1 in this equation. Okay, so then finally একটা লিখি চেষ্টা করি। So finally, how many differential equations, how many differential equations will be required to describe this system? How many differential equations and what will be the order of the differential equations?
ওয়ান ডিফারেনশিয়াল ইকুয়েশন দিয়ে তো হয়ে যাবে যদি 1 + 2 করি, আর পুরোটা লিনিয়ার যদি
না দেখ এখানে হচ্ছে তোর h1 আর h2 কিন্তু দুটো ইন্ডিপেন্ডেন্ট ভেরিয়েবল আছে।
Exactly.
ও আচ্ছা 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 আচ্ছা।
The thing is you have, যদি তুমি ইউজ করো এই সেকেন্ড যে ইকুয়েশনটা পেলাম এই ইকুয়েশনে তুমি q1 q2 পুট করতে পারো, but it will not give you the relation with the input flow.
Yes ma'am.
Our system
it's not, it will not be the linear.
Yes, no লিনিয়ার তো নয়, এটা কোনোটাই লিনিয়ার না।
লিনিয়ার নয় কিন্তু
তো ওয়াটার
অর্ডারটা
ট্যাঙ্ক
কত
লেভেলটা
হবে?
দেখেছি নন লিনিয়ার, লিনিয়ারিটি নিয়ে প্রশ্ন উঠছে না, এখানে হচ্ছে যে ডিফারেনশিয়াল ইকুয়েশনটা কেমন হবে, ডিফারেনশিয়াল ইকুয়েশনটা কেমন দেখতে হবে।
তাহলে ম্যাডাম দুটো আসবে আই থিং লিনিয়ার ইকুয়েশন।
হ্যাঁ, তাহলে দুটো এখানে কি হচ্ছে, দুটো ডিফারেনশিয়াল ইকুয়েশন লাগছে, সে প্রত্যেকটা ফার্স্ট
সাইমালটেনিয়াস ডিফারেনশিয়াল
ডিফারেনশিয়াল ইকুয়েশন। তাহলে আগে যে আমি ডেসক্রিপশনটা বললাম যে ডিফারেনশিয়াল ইকুয়েশন কত অর্ডার, সেখান থেকে আমি বুঝবো যে what is the order of the system. In this case you see there are two differential equations, simultaneous differential equations, দুটোরই ফার্স্ট অর্ডার। তাহলে in that case what will be the order of the system?
ফার্স্ট অর্ডার,
no, first দুটো রাখছি।
আচ্ছা আচ্ছা দুটো আছে, সেকেন্ড অর্ডার।
The order of the system is 2. It requires two first order differential equations. it requires, the description of the system requires 2 first order differential equations. তাহলে এই সিস্টেমের অর্ডার কত? না অর্ডার 2। সিস্টেমটা ডাইনামিক? হ্যাঁ ডাইনামিক। সিস্টেমটা লিনিয়ার না লিনিয়ার না?
নন লিনিয়ার হবে।
নন লিনিয়ার বিকজ এই রুট h,
রুটের ওই এটা
ইনভলভমেন্ট অফ রুট h। কারণ কি এখান থেকে আমি কি কেন বলছি, এই যে আগেই বললাম জাস্ট এখানে যে এই ফাংশনটা যদি নন লিনিয়ার হয়, এখানে ফাংশন কি, এখানে ফাংশনটা কি, এই যে যখন ওয়াটার ফ্লো রেটের জন্য দেখলাম এখানে ফাংশন কি দেখছিলাম, এইটা হচ্ছে ফার্স্ট 0th টার্মের জন্য আমি যদি বলি তাহলে এটা হচ্ছে ইকুয়েশন, এটা হচ্ছে আমার C0, তাই তো? এই জেনারিক ইকুয়েশন থেকে বলতে পারি এটা C0 আর এটা হচ্ছে C1। C0 তে কি আছে, একটা কনস্ট্যান্ট প্লাস a function of h, আউটপুট ফাংশন অফ, আমরা বলেছিলাম প্লান্টটা ছিল x ইনপুট আর y আউটপুট, ফাংশন অফ y বলছিলাম, এখানে ফাংশন অফ h, তার মানে ফাংশন অফ আউটপুট, and the function is non-linear function, therefore the system is non-linear in nature। এখানেও তাই, এখানে we have 2 first order differential equations আর সেটার significance, that therefore the order of the system is 2, and which implies there are 2 energy storing elements, which is significant in this system. There are 2 energy storing elements। আচ্ছা, any of the function মানে any of the this c, এখানে তাহলে কতগুলো ইকুয়েশন পাচ্ছি? C1, জাস্ট আগেরটাতেই যাই, এখান থেকেই দেখে বলো। আচ্ছা, এটা তাহলে আমার this is C0 term and this is C1 term, this one।
হ্যাঁ ম্যাম।
তাহলে C0 C1 implicitly যেটা independent variable t, the independent variable here is t, the input and output are the function of time।
ইয়েস ম্যাম।
তো এটা implicitly ওই ইন্ডিপেন্ডেন্ট ভেরিয়েবলটার ফাংশন নয়। আমরা কি বলছিলাম, ডিফারেনশিয়াল ইকুয়েশনটার কোফিশিয়েন্ট গুলো could be function of input, output or
টি।
এখানে কোনো কোফিশিয়েন্ট নাই, ইমপ্লিসিট ফাংশন অফ t নয়, so therefore the system is time invariant। তাহলে এই সিস্টেমটার আমাদের এই সিস্টেমটার by looking into the mathematical model of the system আমরা কি বলতে পারছি? Order of the system 1, তাই তো?
হ্যাঁ।
Only one energy storing element, order of the system 1, সিস্টেমটা ডাইনামিক, সিস্টেমটা লিনিয়ার না নন লিনিয়ার?
নন লিনিয়ার obviously।
নন লিনিয়ার। সিস্টেমটা টাইম ইনভ্যারিয়েন্ট না টাইম ভ্যারি?
ইনভ্যারিয়েন্ট।
টাইম ইনভ্যারিয়েন্ট। এই ডেফিনেশন গুলো তো তোমরা পড়েছো?
হ্যাঁ ম্যাম।
জাস্ট লাস্ট ক্লাসেই পড়েছো, আমি শুনলাম সেটাই। হ্যাঁ, তাহলে এই by looking into the mathematical description of this kind of simple systems we can comment on the nature, at least the linearity, time invariance, order of the system, these natures we can tell। তাহলে আমাকে একটা এক্সাম্পল বলো যেখানে যেখানে এই সিস্টেমের এই টার্মগুলো, ডিফারেনশিয়াল ইকুয়েশনের টার্মগুলো টাইম ডিপেন্ডেন্ট হবে, ইমপ্লিসিট ফাংশন অফ টাইম থাকবে, মানে টাইম ভ্যারিং একটা সিস্টেমের এক্সাম্পল বলতে পারো?
যদি ম্যাডাম কোনো মানে এক্সটার্নাল ধরুন কোনো ডিস্টারবেন্স আছে তখন?
ডিস্টারবেন্স তো এখানে সব সিস্টেমে তো তাহলে এতক্ষণ পড়ানো তোমার মাটি হলো। সব সিস্টেমে তো, আমরা কোন সিস্টেম নিয়ে কথা বলছি এখানে? এখানে যত সিস্টেম নিয়ে কথা বলছি ডিস্টারবেন্স আছে তো। এই আমরা কি নিয়ে কথা বলছি? এই ইউ টু ওয়াই, এই ম্যাথমেটিক্সটা নিয়ে কথা বলছি। এই যে এত ডিসকাশন, এই সমস্ত কিছু এইটাকে ডিফাইন করার জন্য। ডিস্টারবেন্স মানে তো এই সিস্টেমে এই যে আছে তো আলাদা করে
আচ্ছা
সিস্টেম আমরা কি ডিফাইন করার চেষ্টা করছি ম্যাথমেটিক্যালি দ্য ইনপুট টু আউটপুট বিহেভিয়ার if we provide a input signal how the output will be responding to it how the output signal will respond to the change in the input সেটা আমরা দেখছি যেখানে সমস্ত কিছু ভাবছি ডিটারমিনিস্টিক আচ্ছা এই মডেলগুলোকে আমরা নিচ্ছি সিস্টেমের যে ফিজিক্যাল ল গুলো থেকে ডিজাইন করছি যদি এটা ফ্লো সিস্টেম নিই তাহলে আমরা আর কিচ্ছু ইউজ করিনি শুধুমাত্র ভলিউমেট্রিক ফ্লো এর ইকুয়েশন আর যে একটা একটা রেজিস্ট্যান্স যে ভালভ ইউজ হচ্ছে শুধু ভালভের ইকুয়েশনটা ইউজ করছি তাই তো শুধু ফিজিক্যাল ল গুলো থেকে ডিফাইন করি যদি একটা আরসি সার্কিট নিচ্ছি তাহলে আমি ধরছি যে ওই ক্যাপাসিটরের মধ্যে যেটুকু লাম্পড একটা রেজিস্টার লাম্পড ক্যাপাসিটর নিয়েছি ক্যাপাসিটরটা এনার্জি স্টোরিং এলিমেন্ট how much charge is stored in the capacitor that equation only we are considering তাহলে I want to know whether you can think of any system where this coefficient will be a implicit will be a function of this implicitly a function of this independent variable
ম্যাম ডায়নামিক্স একটা এক্সাম্পল যেটা আমরা আগে করেছিলাম ওই 2 ডিগ্রি অফ ফ্রিডম সিস্টেমে যদি দুটো ড্যাম্পার দেওয়া হয় তাহলে ম্যাম ওটা ওই রকম
2 degree of
2
freedom
ডিগ্রি
system
ফ্রিডম সিস্টেমে যদি দুটো ড্যাম্পার ইউজ করি
লিংক
মানে ধরুন
রোটারি বলছো নাকি এমনি
না
2
ম্যাম
degree
ধরুন
freedom
লিনিয়ার সিস্টেম রয়েছে দুটো স্প্রিং ঝোলানো রয়েছে দুটো স্প্রিং এর
আচ্ছা
সাথে সাথে দুটো ব্লক রয়েছে দুটো ওই ব্লক গুলো আবার একটা করে ড্যাম্পারের সাথে কানেক্টেড আছে
আচ্ছা
এরকম
ঠিক আছে
সিস্টেমের ক্ষেত্রে এটা এই বিহেভিয়ারটা লক্ষ্য করা যেতে পারে
কি টাইম ভ্যারিং
ইয়েস ম্যাম টাইম ম্যাম সরি ইনভ্যারিয়েন্ট
হ্যাঁ
ইনভ্যারিয়েন্ট
অবভিয়াসলি টাইম ইনভ্যারিয়েন্ট কেন কারণ ওই এলিমেন্ট গুলো তো সবই তুমি তো বলে দিলে মাস নিচ্ছ দুটো
ইয়েস
মাস
ম্যাম
দুটো এনার্জি স্টোরিং এলিমেন্ট এটা তোমার তো আর কিছুতে চেঞ্জ তো নেই টাইমের সাথে ওই যে
হ্যাঁ
মাস স্প্রিং কনস্ট্যান্ট ড্যাম্পিং কনস্ট্যান্ট এর নেক্সট ক্লাসে আমি মেকানিক্যাল একটা সিস্টেম নেব সাসপেনশনের সেটার মডেল করব তো ওখানে তো কিছু করার নেই
ইয়েস ম্যাম ওটা ইনভ্যারিয়েন্ট হয়ে যাবে টাইম ইনভ্যারিয়েন্ট হয়ে যাবে
হ্যাঁ তাহলে আমার কোয়েশ্চেনটা কি বুঝতে পেরেছো সবাই আমি বলছি ডিফারেন্সিয়াল ইকুয়েশনটাকে এইভাবে লিখছি তো জাস্ট এরকম ভাবতে পারি এভাবে চলতে থাকলো সি nth টার্ম পর্যন্ত আমি ধরলাম nth টার্ম পর্যন্ত আছে আর লিখতে পারছি না ইকুয়াল টু xt এই তো আমি বলছি ইকুয়েশন যেখানে আমার সিস্টেমটা হচ্ছে x ইনপুট আর y আউটপুট তাই তো এটা একটা জেনারিক ডিফারেন্সিয়াল ইকুয়েশন লিখতে পারছি সেখানে আমি কমেন্ট কি করলাম যে যদি C1 C0 এই যে পরপর বলছি C0 C1 এগুলো যদি সবগুলো how do you define whether the system is linear or non-linear কি করে বলবো by observation only শুধু অবজারভেশন কিছু ভাবতে হবে না আমাকে if we try to decide upon whether a system is linear or non-linear what is the way out how to test whether a system is linear or non-linear
the degree of the differential equation should be
না এটা তো আমি এখন অবজারভেশন থেকে তোমাকে আজকের ক্লাসে বলার চেষ্টা করছি তুমি তাছাড়া কিভাবে করো এমনি লিনিয়ার না নন লিনিয়ার জানো কিভাবে কি করব আমরা, যদি একটা সিস্টেম দেওয়া থাকে x হচ্ছে ইনপুট, তার y আউটপুট, কি করব আমরা, we will take a input x1, so for that we will get a output y1.
আচ্ছা আচ্ছা, স্ট্রেট লাইন হবে কিনা সেটা।
হ্যাঁ, তাহলে ফার্স্ট এই লিনিয়ারিটি চেক করার জন্য প্রথম কথা হচ্ছে সুপারপজিশন দেখতে হয়। সুপারপজিশন কি না, x1 দিলাম, y1 আউটপুট পেলাম, if we provide a input x2 and I get a output y2, then what I will do, if I take a combination of x1 x2, alpha x1 plus beta x2 as my input, then if the
আউটপুট উইল
system
বি
is linear, the output will be alpha y1
প্লাস বিটা বাই।
plus beta y2. And this is এইটা তো একটা কনভার্সন, একটা প্রসিডিউরের মধ্যে দিয়ে যেতে হবে, তাহলে জানতে পারবো লিনিয়ার না নন লিনিয়ার, তাই তো? এখন যখন আমরা মডেলিং করছি, দেন থ্রু দ্য ম্যাথমেটিক্যাল ডেসক্রিপশন অফ দ্য সিস্টেম আমি কি করে জানতে পারি, এই এত কিছু ইনপুট, দুটো ইনপুট, তিনটা ইনপুট না দিয়ে আমি ডাইরেক্টলি বাই সিইং দ্য ম্যাথমেটিক্যাল ডেসক্রিপশন কি করে আমি বলতে পারি, কি করে বলতে পারবো না, if I see that C0, C1, Cn, all these are
either constant or a function of t.
they are linear in x and y যদি হয়, মানে তারা these are only either constant or only function of time. Okay, if they involve y or x or any combination of x and y, then they are non-linear in nature. ঠিক আছে, যদি যদি শুধুমাত্র this is only y সে, তাহলে কোনো প্রবলেম নেই, এই ফাংশনটা তাহলে লিনিয়ার ইন y। এটা যদি শুধুমাত্র x হয় তাহলেও কোনো প্রবলেম নেই, ইফ ইট ইজ x স্কয়ার or x into y or root over of y or some other function which is not linear, then the system is non-linear. Okay, কেন আমি আগের এক্সাম্পল গুলোতেই আমরা দেখে নিয়েছি, আগের এক্সাম্পল গুলো দেখে নাও তাহলেই বুঝতে পারবে। এই যে এটা হচ্ছে আরসি সার্কিট, আরসি সার্কিটের এক্সাম্পল ইউ সি দ্য ফার্স্ট টার্ম, এটা কি C0 টার্মটা আমার, C0 is equal to only y, C0 is equal to y, either constant or function of time or a linear thing, so therefore the system is linear. যদি তারও আগেরটাই যায়, এটা কি ছিল, এটাতে ডিফারেন্সিয়াল ইকুয়েশনই না, এটাতে কি শুধু C0 টার্মটাই আছে, দেখো y, এখানে y হচ্ছে আউটপুট, y is equal to some constant into x, তাই না, ওই ফাংশন থেকে দেখলে। ফার্স্ট টার্মটা শুধু আছে, সেখানে ডিফারেন্সিয়াল ইকুয়েশনও নেই, এটা একটা অ্যালজেব্রিক ইকুয়েশন, এটা স্ট্যাটিক সিস্টেম। নেক্সট যে এক্সাম্পলটা দেখেছিলাম আমরা, ফার্স্ট অর্ডার ডাইনামিক সিস্টেম, লিনিয়ার টাইম ইনভেরিয়েন্ট, ঠিক আছে, ফার্স্ট অর্ডার একটা এনার্জি স্টোরিং এলিমেন্ট, লিনিয়ার টাইম ইনভেরিয়েন্ট। নেক্সট আমরা দেখেছি ফার্স্ট অর্ডার নন-লিনিয়ার টাইম ইনভেরিয়েন্ট। Okay, I'll be back. Okay, the next example we have seen is second order non-linear, তাই তো? Whether time varying or time invariant?
Time invariant.
Time invariant. Okay, so what I am asking is, then I know you can by observation you can check whether it is linear, whether it is time varying or time invariant, and what is the order of the system. These three things you can check by observation. So the question is, can you give me one example of this time varying system? One time varying system. With this, we will end. Therefore, to be a time varying system, this C, this coefficient C should be C0 or C1. Any one of this should be a
Function of x or y. I
x.
think it.
No. Time varying. I am talking about time varying. It should be explicit function of t.
Oh, sorry, madam. Time varying. Okay,
Time
okay.
varying. Time varying. Linear or non-linear, I am not bothered about this. For this example, say so. Therefore, you take any of the examples. If these any of the coefficients, the system parameters, say C or this R, K, any one of this, if they are time dependent, if they are varying with time, if the value of that system constant is changing with time, then this coefficient will be a explicit function of time. Do you agree?
Yes, ma'am.
Hey, the example you were giving, one spring mass damper system. So you can model a vehicle that is moving as a combination of spring mass damper. Okay, now if you consider the fuel mass also contributing to the mass of the vehicle, so that is varying with time. Do you agree?
Yes, ma'am.
So now if you model that mechanical any mechanical vehicle, so for bicycle there is no change in fuel. For example, you see, for bicycle there is no change in fuel, so therefore the mass you have considered for the model will be constant throughout time. Now if you move to a fuel car, with time the fuel because of the combustion, there will be a change in, if you consider the mass of the fuel with the mass of the vehicle, so therefore there will be a change in the mass of the vehicle itself. Huh.
Yes.
So but for car also, the change in the mass of the fuel is negligible with respect to, or the rate of change in mass is negligible. But if we go for a rocket,
Rockets.
rocket, so what will happen? It will be a significant amount of mass which will be burned, and there will be a significant rate of change in mass. So in that case, for the model of the rocket, there will be, if we consider the mass of the fuel that is used, it will be, there will be a significant change with time in the mass. So therefore the model of the rocket will also be a time varying model. Do you agree? The aim involved will be a function of time itself. So therefore it will reflect in the coefficient of the differential equation, and that will be a explicit function of time. Okay. So if you have any question, you can ask. Otherwise, we will conclude the class here.
Ma'am, I have a question. As I'm from production engineering department, my differential equation part is a bit weak, ma'am. So from where should I study it?
Differential equation.
Yes, ma'am.
You can
Some
study
of the
from Grewal.
things which are ma'am which are teaching in class is I cannot follow with it.
Can you tell me from where you could not follow?
I'm the part of the parts where ma'am tank one when we are doing the coupled tank system.